Okay, so today as we go into our last and final form of how we can write a linear equation, we know standard form, we know slope-intercept form now. Now we have one that's actually a little longer and harder to remember how it goes. It's point-slope form. So point-slope form of a linear equation, I write it right here for you. If you need to circle it so it'll stand out on your paper, that's the next one you need to learn. That's the next one you need to memorize. Okay? It goes like this. Y, no subscript, just y minus y sub 1. In other words, we're not going to replace the y, but we are going to replace the y. We know that that y subscript 1, y sub 1, is a y value from a certain point, equals m. We know what m stands for. What does m stand for again? Slope, okay. So m is the slope of the line. M times, in parentheses, x, notice no subscript on that first x, but it says x minus x sub 1. So the x sub 1 and the y sub 1 come from a point on the line. Doesn't mean that the other x and y can't be a point, it's just that we are focusing in on, when we have point-slope form, we can pull out a point from it, and we can pull out the slope from it. Just like when we have slope-intercept form, we can pull the slope out of it, we can pull the y-intercept out of it. So here's the first thing that we're going to practice today. Identifying the point and the slope to help you graph the equation given in slope-intercept form. So the equation is going to be given to you in point-slope form. Y minus 1, see there's something being subtracted from a y value, equals 2 times x minus 3. That's point-slope form. So what we have to decide is what's the point that is being represented in this equation, looking at our point-slope form model, and what is the slope, and then we'll use that to help us graph it. So what is the ordered pair that we can pull out of that equation? Point-slope, remember, goes like this. Y minus y sub 1, y minus y sub 1 equals m times x minus x sub 1. So what's being subtracted from the y? 1. So that means the y value of our ordered pair is 1. What's being subtracted from the x? 3. So that means the x value of our point is 3. So we can pull out of that equation, we can say, oh, that is showing an ordered pair 3, 1. What's the slope of this equation? 2. Okay? All it takes is 1 point and the slope to help us make other points, and we can graph this. So how can we treat that 2 again as slope, rise over run? What can we do? 2 over 1, which is up 2, right 1, or what's the other way? Negative 2 over negative 1, which is down and left. Okay, go ahead and graph that line that belongs to that equation given to us in point-slope form. And again, your line is going all the way through the graph. And you're stopping to ask yourself, I identified that there was a positive slope for this equation. What should the behavior of the line be then? What should the behavior of the line be if it has a positive slope? What's positive behavior for a line? Rising from left to right, yeah. And our line is rising from left to right. Okay, you go ahead and start number 2. You identify the point, the ordered pair. So why don't you write down the word point so that in your notes when you look at this you can say, here's what I was identifying. Identify what you think the point and the slope are that are represented in this equation. So you have to pick out an x and a y value. An m value. Okay, who wants to offer up what they think is the ordered pair being represented in this equation? Austin? 2, 4. Guys agree with them? Okay. People shaking their head, yes? I know. It is Benton. Anybody else? It is Macy. How come? Why? Negative what?
4.
Negative 4. So Avery says, let's change that to a negative 4. Now do we agree? Those of us who were disagreeing before, do we agree now? No? Okay. You know what might be helpful in this one? Is change it so it's got subtraction like it's supposed to have. And then maybe, just maybe, it will be a little easier. So why? Well, it's already got subtraction, so no reason to change it, right? On that side. Equals negative 3/4 x, but it doesn't have subtraction. So I can change that to subtraction, and just like addition, when I change it to subtraction, I have to change what was being added to its opposite. So what's the opposite of 2? Negative 2. So what's being subtracted from y? Negative 4? No, a positive 4. It's right here. 4 is being subtracted from y. So we don't want to make that 4 negative in our ordered pair. We want it to be positive. And then what's being subtracted from the x value? Negative 2. So we need our x value to be negative, not the y value. So our ordered pair is really negative 2, 4. What's the slope? I'm guessing that went much better. What is it? Negative 3/4, yeah. Okay, go ahead and graph. Ordered pair, when we have a slope of negative 3/4, that means that we can give the negative sign to the 3, which means down and right, or we can give it to the 4, which means up and left. So we have to know the 2 different ways we always have of using our slope. Uh-oh, I've got into my territory where I was writing. Okay. Slope was negative. We expect the behavior to be falling from left to right. My line's falling from left to right. How about yours? Okay. Okay, try again. See if you can get this one, number 3. What is the ordered pair? Might be a good idea, first of all, to do this. Change this to subtraction. Change this. Oh, we don't need to change that one. So I would suggest this would be a first move, is to change it so it's y subtract instead of y add. Okay, what's the point we can pick out of this one? Who thinks they have it? You're feeling really confident about this. Go for it. Riley?
4 negative 3.
He says the point that we can pick out of this one is 4 negative 3. Anybody agree with him? You all should. Because when we change that to subtraction, it's subtract a negative 3. So it is a negative 3 for the y value, a positive 4. Now, here's where you're going to mess up. Typically, this is what happens to students. Maybe you don't, if it's addition, you don't take the time to think of it as subtraction and what would be being subtracted. But here's what more commonly happens. You write down this one, the negative 3, as the x value, and this one, the 4, as the y value, because that's the order they came in the problem. But in the ordered pair, the x comes first, and it's the one over here at the end, and the y comes second, and it's the one at the beginning. So typically, what a student would do, without just being in a hurry, they would say they have ordered pair negative 3, 4, and they'd have the wrong point. Okay? So be careful of that. Just because this is the first value does not make it the first value in the ordered pair. Okay, what's the slope for this one? 0. 0. Stop and think. When a line has a slope of 0, what's its behavior?
Horizontal.
It's a horizontal line. Good job, Tate. It's a horizontal line. So you know all you have to do for this one? You have to put this point on the graph, 4, -3, and draw a horizontal line going through it. That's all you gotta do. You don't need 3 points for this one. I'll let you off with 1. So I want you to put in your notes, though, that this tells us we have a horizontal line. That was why we only plotted the 1 point, because a horizontal line, really, you can get away with just having the 1 only because we're using the coordinate plane and the grid line kind of serves as our horizontal line. Okay. Anybody have any questions on being able to identify an ordered pair and the slope from a linear equation written in point slope form? Okay, now let's go to the back side and see what we're doing back there. Write the equation of the line. Okay, now they're giving you the point and the slope and saying you write the equation of the line in point slope form. Okay, so, well, here's point slope form again, right here. And I suggest that's just exactly how you substitute things into it and then clean it up afterwards if there's any cleaning up to do. And cleaning up, I mean, you know, like, can we change subtracting a negative to adding? Okay, so we're going to substitute. This is our m value. This is our x sub 1. This is our y sub 1. So it's y subtract, that's what it says. Y sub 1, we have a 6. M, 1/5. X, subtract the x sub 1 value, which is -2. This one can be cleaned up. Y subtract 6 equals 1/5 times x plus 2. That's how we would see it written in point slope form in an answer, just like on the front. They gave it to us in cleaned up form, and then we had to pull the point out of it and know that, you know what, that x plus 2 actually came from a subtraction problem. Okay, you try to number 5. Write that one in point slope form. A line that has a slope of -4 and ordered pair 0, 3. Got this, Chase?
Maybe.
Okay, what is it?
Y minus 3 equals -4. Then x minus 0.
That's right, he's got it. Any cleaning you have to do? No. We don't have any subtracting and negatives going on, so we can just leave it like it is. And we also don't, one thing you might be tempted to do is clean up this 0 because you're saying, wait a minute, when you subtract 0, it's not going to change anything, that would be x. Well, if we clean it up, we're not really truly showing true point slope form. So we just leave it like this. Questions? Okay, here we're going to get some practice apparently that some people still need in here on finding the slope when you're getting 2 ordered pairs. How do we find the slope using the slope formula? Because in this one, we can't write an equation in point slope form because they didn't give us the slope. They only gave us 2 points. So we have to find the slope. We need to use our slope formula to find slope. So let's go ahead and get that done. We will substitute in, you get to pick which one's going to be your x sub 1, y sub 1, which one's going to be your x sub 2, y sub 2. You get to make that call. This should not be something I need to be practicing with anymore. This should be ingrained already. You should know how to do this. I get -6. What do you get? Anything? Anybody use this one as your starting one and you did 3 take away -3 and 9 take away 10, because you could, then you did 6 positive 6 over -1, which is still a -6. Okay, now that we have the slope, this is where we can have different answers than somebody else at our table or across the room or wherever, because you only need 1 point and the slope to write an equation in point slope form. So let's just show both of them in our notes, but we really only need to write 1. So we have, let's start with 9, 3, and m equals -6. So this is our x sub 1, y sub 1. Y subtract what? 3 equals -6 times x subtract 9. Here's 1 point slope. Well, would you write this in your notes, please? 1 point slope form name for this equation. This is just one of them. How many point slope form names do you think there are for any given linear equation? Just 4? 3 because I make you do 3 points to graph it? Did I hear infinite? Why infinite? Because you're right. Why would there be an infinite number of point slope form names? Or because there's an infinite number of points on any given line. That's why. Any point you can take off of that line could be put into that equation. How about slope-intercept form? How many names are there for any given line in slope-intercept form?
Infinite.
How many slopes does a line have? 1. How many y-intercepts does that line have? 1. So how many different names can there be? Only 1. There's only 1 name in slope-intercept form. Okay. Let's do this other one. We got one more of these to do yet. Because but you can put a big fat or here. You don't have to do both of them, but in your notes I want you to have both of them. We also could work with the other ordered pair, which is what again? 10 -3. And m equals -6. Here's another of the infinite names this line could have. So we're going to do y subtract what? -3 equals -6 times x subtract 10. Should we clean this one up? Yes. What should this become?
Y plus 3.
Y plus 3 equals -6. Should we clean that up? X minus 10? No, leave that as it is. Okay, here's another. And I want you to put this in your notes. Another point slope form name for the same equation, just using a different point from that linear equation. Questions on these 2 types of things that we worked with today? Okay, then let's give those of you who need to finish up the other assignment.